Question number 2 here. It is possible for object moving non-zero velocity. So we see we have the value of the velocity, but zero acceleration. Meaning you have object with a velocity v, but the magnitude of the acceleration of the object is 0. The answer is yes. So it happens when the velocity has constant value, right? Constant value, we produce acceleration 0, meaning no increase or decrease the value of the velocity or non-zero velocity. Okay, we go to the question number 2. A car is capable to accelerate 0.60 meter per second square. Calculate time needed for car to go from speed 5.5 meter per second to speed 8 meter per second. Meaning the object accelerate from 5 to 8 meter per second, and the acceleration is 0.6 meter per second square. So what is the time taken for the process here? So here you can use the equation v is equal to u plus at. Because of the value from the question, so we have the value of the final velocity 8 meter per second, and we have the value of initial velocity is 5.5, and we have the t acceleration is equal to 0.6. So now you can find the value of time t is equal to 4.17 second. Second. Okay, number B. A ball is thrown upward from the ground with the initial speed 25 meter per second. At the same instant, another ball dropped from 15 meter buildings. When will the two balls will be meet at the same height from the ground? Okay, first I think you can draw the diagram here. Let's say this is the ground surface, and you have the object. The first object is start from the ground and throw upward with the initial velocity to 25 meter per second. So this is u. And the second ball here, okay, we have second ball. This is first ball, and the second ball with the distance from the highest level to the ground surface here is 15, right? 15 meter. Okay, so now what is the time when the ball will be at the same height? So meaning what is the time taken for the ball, maybe the ball and ball 1 and ball 2 collide. Let's say the position is here, right? So what is the time here? Okay. First, you can consider the time, the distance here. Let's say I draw this is S1 from ground surface to the point where the ball 2 meet ball 1. So here is S1, right? So for the S1, so you can use the equation u t minus half t squared. And the item here, we talk about the S1, all the motion of the two objects is on the vertical axis. So meaning we have this is y and this is also uy, right? So now for the S1 here, let's say U1, the ball 1 thrown upward with the 25 t uyt minus half, g is 9.81, and this is time taken, t square, for the time t from the ground to the point here, for the S1, right? So this is the, okay, let's say you have a first equation, equation number 1, and the second part, so you can use the second part for the ball 2. Ball 2, let's say here, this is S2. Because the total height here is 50 meter, okay, let's say we have a S1 here. Okay, I use S1 here is a, let's say H1, height of, for the ball 1, H1, right? And the S2 here is a, H2 here is refer to the height of object 2 from top to the point here is a H2, but total displacement here is 15 meter, so meaning H2 here is equal to, sorry, S2 here is equal to 15 minus H1, 15 minus H1 is equal to the distance here, or S2, right? S2. Okay, so we go to the, continue to the equation here. So for the second ball, also we have a S2, right? S2 is equal to ut minus half gt square. So now all the item here, because on the vertical axis, so we have y, this is also y. But for the S2 here is a direction to downward, so meaning you must use a negative. Negative S2 is equal to, H2 is equal to 15 minus H1, right, is equal to ut here, because the objects is dropped from 15 meter volume, meaning start with the initial velocity u, so time t minus half, and this is 9.81 and t square, right? T square. So now you have let's say this is equation number 2. But if you look at the equation 1, okay, equation 1 here, so we have S1 here. S1 here is referred to the H1, right? H1. So we have the item H1 and H1 for equation 1 and equation 2. Also we have the item T and T square and the T square for the both equation 1 and equation 2, meaning you can use the equation 1 or equation 2, equation 1 minus equation 2, right, to find the value of the T here, because the value of the G is the same value, G, magnetic gravitation acceleration. So here we can use the H minus 15 minus H1 here. Let's say we have H1 is equal to 25 T minus 9.81 divided by 2 times T square, and we have another equation here, for the S2 here we have 15 okay, minus H1 is equal to, this is 0, right, minus half 9.81 T square. So equation 1 minus equation 2, right? So H1 minus 2 here, so we have a, so I write here, so we have a minus, we have a 15, and now we have the T cancel, so we have a, for the T square we have a 25 T, right? And the last answer you can find the value of the, so I write here, so the T is equal to 15 divided by 25 is equal to 0.6 seconds. So this is the final answer. time taken for the two balls will be at the same height from the ground, meaning we have a same value of s displacement. Okay class, that's all. Thank you.